Hello Year 11 and welcome to your next geography lesson. In today's lesson, we are going to be needing to use our knowledge from the previous lesson where we looked at convection currents to learn about the 4 different plate boundaries. So in terms of where we are in relation to this topic, we are looking still at this third section on plate boundaries. So before we do this, we need to make sure we understand what convection currents are. So we need to consolidate our knowledge from the last lesson, because all of these plate boundaries that you can see on this image all occur because of convection currents. So the first thing that you need to do is go through this paragraph and fill in the gaps. So the inner core is, well, how many degrees is it? So remember we said it was as hot as the sun. The heat rises from the inner core and makes its way to the mantle. So that's where we have this hot viscous magma, which is what it says there. And as the magma rises towards the crust, remember that it starts to cool. So as it cools, it sinks inside the mantle, creating what we're talking about here, these convection currents, where they either move towards each other or they move away from each other. Now, where convection currents are diverging, the plates are moving apart. So you can see that happening on this diagram here. So the plates are moving away from each other. And similarly, with this diagram here, the plates are moving away from each other. However, when convection currents diverge, so when they are moving towards each other, the plates will move towards each other. And you can see that happening in these images here. So the second image, they're moving towards each other, but one is sinking and one will be forced upwards. And then in this one, they're both being forced upwards. So we need to look more carefully at these 4 different plate boundaries. And the 4 different plate boundaries are all dependent on what the convection currents are doing and also whether the crust is oceanic or continental. So let's move on then to look at constructive plate boundaries. So at constructive plate boundaries, you can see that the plates are moving away from each other, which suggests that the convection currents were also moving away from each other. So if the convection currents are moving away from each other, the plates on the crust will also move away from each other. So what type of things can we add to this? Well, it might be worth writing that this is the mantle, and that's where we have the hot viscous magma. It might be worth writing here that this is a gap in the Earth's crust. And also it might be worth writing down something about the fact about what the plates are. So this is known as the North American plate. So you'll have to think back from your work from last week. So this is the North American plate. And then this plate here is the Eurasian plate. Okay, so how do constructive plate boundaries form? Well, the convection currents in the mantle, they drag the plates apart. So the plates are being dragged apart, okay? And as the plates move apart, magma rises between them. So as the plates move away, the magma finds a gap in the Earth's crust and then that can escape. So you can see that here, the magma can rise upwards. Now, as it reaches the Earth's surface, it's very cool. So what will happen is that because the temperatures have cooled, that magma will start to harden and solidify. So magma, when it reaches the crust, hardens and solidifies, and it creates new rock. Now this rock actually is creating the ocean floor, and this example where the North American plate and the Eurasian plate is moving away from each other is known as the Mid-Atlantic Ridge, and you can see that in the middle of the Atlantic Ocean. So at constructive plate boundaries, we see things happening like volcanoes because there's a gap in the Earth's crust, and also earthquakes because the plates are moving, so there's going to be lots of fracturing. Okay, so once you have annotated your diagram and you've put the 4 statements in the correct order, then we're going to move on to look at destructive plate boundaries. So what are destructive plate boundaries? Well, straight away you can see that these plates are moving towards each other. So the convection currents within the mantle must have been moving towards each other. Now we'll notice that as these plates move towards each other, they don't both do the same thing. And that is because one of them is an oceanic plate and one of them is a continental plate. Now think back to last week when you annotated the 2 different crusts. Oceanic crusts are denser and they're heavier, which means they're more likely to sink. However, continental crusts are lighter and less dense, so they're less likely to sink. They're more likely actually to rise. So as these 2 plates move towards each other, we will see the oceanic crust sinking, and that will sink and move into the magma. Now, as it moves into the magma, it will start to melt. So the oceanic crust is actually being destroyed, whereas the continental crust actually can get forced upwards, and that can create things like volcanoes and mountains. Okay, so we can have mountains forming and also volcanoes. And the reason that the volcano can occur is because when one plate sinks and this plate moves towards it, they will start to fracture. So when this one melts in the magma, it will create lots of fracture lines in the Earth's crust, which then allows the magma to escape up through it. So at destructive plate boundaries, they're known as the most, they destroy. They destroy land, they destroy the oceanic crust, and they also destroy the land because they lead to earthquakes and also volcanoes. Okay, so that's a good way to remember what the destructive plate boundary does. Similarly, when we looked at the constructive plate boundary is actually creating new land. It's constructing land. As the plates move away from each other, new magma rises, hardens and creates new crust, which makes new land. So let's move on then to the next one. So the next one is the conservative plate boundary. And at conservative plate boundaries, you will see that the plates, they don't move away from each other, they don't move towards each other, they actually slide past each other. And there's 2 ways in which they can slide past each other. They can either move in the same direction at different speeds. So one will be moving faster than the other, or they can move in opposite directions at the same speed. So you'll notice that as regardless of which one they are, there's going to be lots of friction built up between the 2 plate boundaries, which will lead to earthquakes. So conservative plate boundaries are different because there aren't any volcanoes. So there's no volcanic activity because there's nowhere for the magma to escape from. But there are a significant amount of earthquakes. Now, what we have here are 2 continental plates. So this is a continental plate, and this is also a continental plate. Okay. Now, as an earthquake occurs, that will create shock waves. So if this was the focus of the earthquake, the epicenter of the earthquake, that will then create shock waves, which you can see on your diagram here. So the closest you are to the focus of the earthquake, the stronger it will be, and the further away you move from the earthquake, the less strong and less powerful the earthquake will be. So remember that conservative plate boundaries, like constructive plate boundaries and destructive plate boundaries, they all occur because of convection currents. So the convection currents is the first thing that happens, and then you decide which statement is 2, 3, and 4 and put them in the correct order. Now, the final plate boundary that we need to look at is a collision plate boundary. And when you think about collision, you think about things colliding. So they're moving towards each other. So the convection currents at this point are moving towards each other. So it's kind of similar to destructive plate boundaries. However, the difference between destructive plate boundaries and collision plate boundaries is that at destructive plate boundaries, we have an oceanic plate and a continental plate, whereas at collision plate boundaries, we have 2 continental plates. So remember that if they're both continental plates, they're going to have the same density, they're going to be the same thickness, and they're going to be the same weight. So they're not going to be able to force one or the other down. They actually force each other up. So as the plates collide, they are forced upwards. And that leads to what we have here, fold mountains. So an example of fold mountains are the Himalayas, so Mount Everest in Nepal, okay, which actually grows in height every single year. So it's getting taller every single year because the convection currents are constantly moving these 2 continental plates towards each other, which means that these fold mountains will get higher and higher every single year. Okay, so make sure please that you've annotated your diagram, you've drawn some little things to help you, and then you've put the statements in order from 1 to 5. Now remember that at this one, they're being forced upwards, so there's no gap in the crust that magma can escape through. So there will be no volcanic activity. Okay, so task 6 then. Most likely to be what? So you need to use this image here to decide which plate boundary you think occurs at which of these different parts of the crust. So, for example, the North American plate, which is here, and the Pacific plate are moving in the same direction. So if they're moving in the same direction, it means that one of them is moving faster than the other. So this would be an example of a collision plate boundary. Oh, sorry, that's wrong. I meant to say conservative. Sorry. Now, the Nazca plate and the South American plate, you have to actually look at the plates. The Nazca plate is on the oceans, so it's an oceanic plate, whereas the South American plate is continental. So we know that the 2 plates are moving towards each other, but then we have to decide, is it a collision plate boundary or is it a destructive plate boundary? So remember, at collision plate boundaries, that's 2 continental plates, whereas at a destructive plate boundary, we have an oceanic plate and then we have a continental plate, and this means the oceanic plate sinks and the continental plate rises. So the Nazca plate and the South American plate is an example of a destructive plate boundary. Okay, so do the same thing for the South American and the African plate. Do the same one for the North American and the Eurasian plate. You could do the same for the Eurasian and the Pacific plate, and also the Eurasian and the Indo-Australian plate. And simply decide whether you think it's a constructive, a collision, conservative, or a destructive plate boundary. Then you need to make sure that you submit all of your work into the assignment that's been created for you. And if you have any questions during any of the activities, please send me a message on It's Learning.